Unit 3, Level 2, Lesson Topic 2, solving one-step equations with multiplication and division. This lesson has the same essential question as the last lesson because we're still looking at the same idea. The essential question we're going to be exploring is what is the connection between inverse, balance, and solving equations. In the last lesson, we looked at this connection for multiplying or for adding and subtracting. In this lesson, we'll look at the connection for equations that involve adding and subtracting. To review, an equation is simply a statement of equality, and that means that both sides of the equation have the same value. There is only one solution to an equation, and the solution to the equation is the value for x that makes these two sides balanced. Right? So in other words, we're looking for what number can I substitute in for x that will make 3x have the same value as negative 12. So other than doing this in your head, really the best way to do this is to using the idea of inverse and balance to manipulate equations and get the variable by itself on one side of the equal sign. So in other words, we take, like if you look at our example, to get x by itself, it would look like this. The lesson that we're going to do today is all about how do we go from this kind of an equation to this kind of equation where we can find the value of x. We're still going to be using the concept of inverse operations. Remember that if you have an operation you want to undo to get x by itself, you have to do its inverse. In this case, the inverse operation of multiplication is division. And make sure you're writing this down. And then the inverse operation of division is multiplication. If you recall from the last lesson, the steps for solving algebraic equations are that you do the inverse operation on both sides of the equation, and then you check your solution. And always remember balance. So what you do on one side of the equation, you have to do to the other side. Make sure you write that down. All right, let's look at our first example. 3 times x equals negative 12. Remember, when you have a 3 next to a number x, that means multiplication. I bring that up because in order to solve this, we have to identify the operation and do its inverse. So when you see 3x, you really should be thinking 3 times x. So then what is the inverse operation of multiplication? Division. Now, we don't show division with the division symbol in equations. We show it with the slash, like this. Okay? So instead of saying 3 divided by 3, we write it as 3 over 3. But remember that a fraction means division. So I am showing division here. So there's my inverse operation. And then remember, what I do to one side of the equation, I must do to the other. So on the right-hand side, instead of saying negative 12 divided by 3, I write it as negative 12 over 3. But it means the same thing. Then I divide. 3 divided by 3 is 1, which is what I wanted. I wanted x by itself. And then remember here on the right-hand side that you are dividing a negative by a positive. A negative divided by a positive is a negative. So negative 12 divided by 3 is negative 4. Now, how do I know I got that right? Well, if I got that right, if this is my one solution to my equation, then I should be able to substitute it back in here and show that when x is negative 4, that the left side balances the right side, that they have the same value. So let's see. Here's my original equation. 3 times x equals negative 12. I replace x with the solution I came up with, which was negative 4. And then I multiply. 3 times negative 4, a negative times a positive is a negative, so 3 times negative 4 is negative 12. And sure enough, that means that the left side of the equation has a value of negative 12, which is the same as the right-hand side of the equation. So since the equation, both sides have the same value, I have just shown that my solution for x was negative 4. My answer was correct. Finally, don't forget to graph your solution. If the solution is x equals negative 4, I go and I find -4 on the number line, and I put a closed circle. And that should be closed. If you can't see, there is yellow in there. It kind of looks like it's hollow, but it's not. So make sure you have that as a closed circle. Example number 2. Again, I have a number next to a variable with nothing in between them. So that means that the operation that you see here is multiplication. This is -2 times y equals 26. The inverse operation of multiplying is dividing, so I will divide both sides by -2. Please do not change the sign of the number. Remember, we're not doing opposites. We're not changing from a -2 to a +2. Here, we are doing inverse operations, which means that we keep the number exactly the same, and we do the inverse operation. So instead of changing from negative to positive, here, we do the inverse operation, meaning we switch from multiplying to dividing. So we show division using a fraction. We put it over -2. And then what I do to the left-hand side, I must also do to the right-hand side. So I do 26 over -2, which represents 26 divided by -2. A negative divided by a negative is a positive. So -2 divided by -2 is 1. That's what I wanted. So then I have y by itself on the left-hand side. And then on the right-hand side, a positive divided by a negative is a negative. So I have 26 divided by -2 is a -13. Again, to check my solution, if -13 is correct, I should be able to substitute it into the equation and show that the left-hand side and the right-hand side have the same actual value. So I rewrite the equation and I substitute in -13 for y. A negative times a negative is a positive, so the value of the left-hand side is 26, which is the same as the value for the right-hand side, so this is the correct solution. Again, make sure you graph your number. So y equals -13. You would go here on the number line, go down to about right here, and put a dot at -13, like so. All right, let's look at a division example. As you can see here, I have p over 2, and if you recall from our previous examples, if it's written as a fraction, this means division. So since I'm dividing by 2, I have to undo division by doing the inverse operation. The inverse of division is multiplying, so I will multiply the equation, or that side, by 2. And then what I do to one side, I must do to the other to balance the equation, so I will also multiply 16 by 2. Here on the left-hand side, the 2's cancel, which is what I wanted, and I get p by itself. And then on the right-hand side, 16 times 2 equals 32. I can check my answer by substituting p back into the equation. P was 32, so I replace p with 32, and I divide. 32 divided by 2 is 16, so the value of the left-hand side is equal to the value of the right-hand side, and the correct value of p is 32. I know my answer is correct. Then please make sure that you graph p equals 32. So you would start at 0 and go all the way to the right over here to about 32 and put a closed circle, like so. At this time, you're going to write your summary. The essential question you're going to answer is the same as in the last topic, but you're going to do a different summary because we're answering the same essential question, but now you need to expand to talk about multiplication and division. The essential question for last topic and this topic was, what is the connection between inverse, balance, and solving equations? In this summary, you want to talk about the connection between inverse operations, balance, and solving equations when you have equations that include multiplying and dividing.